My name is Gregor-von-Laszewski. I'm the Assistant Director of the Digital Science Center, and I'm also an Adjunct Associate Professor of the Intelligent Systems Engineering Department. My address you see here, I'm in Smith Research Center, and I use typically the email laszewski@gmail.com, and my website is on GitHub, so you can go to this and find out more about myself. For classes, please don't use my regular email address. I just use the class communication mechanism, which is typically a Piazza, in which you can ask questions. Today I will be introducing you in some of the research topics I'm interested in. And we are starting with cloud and big data architectures. In here, we have two components. One is the cloud component, and then the other one is the big data architecture that is typically used by data science and to enable data science. When we look at cloud computing, I have used a common picture from Wikipedia that shows that it's an integration of infrastructure, platform, and application that can be hosted in the cloud. A wonderful definition of cloud computing has been provided by NIST. Cloud computing is a model for enabling ubiquitous, convenient, on-demand networking access to a shared pool of configurable compute resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. That means you can essentially configure your own infrastructure and services on that infrastructure, and you can provision them conveniently. In addition to this, we want to use big data, and as part of this, we sometimes need to be learning a lot about what data science architectures comprise and which components are included, and also what you as a data science student may actually need to learn. This includes everything from programming, statistics, some fundamentals, machine learning, toolboxes, visualization, data integration, data mining, text mining, and naturally also big data tools and services. Naturally, we want to actually intelligently use these components so that we are optimally utilize the infrastructure and also the services. And as part of this, our mission is to provide intelligent cloud computing environments and services. So you use these resources in the most efficient manner to create cloud computing environments. You develop applications that benefit or motivate such cloud environments. And you research and use state-of-the-art technologies that bring forward the next generation of cloud environments. Naturally, as you can see, this is a pretty important aspect of what we want to do in the future. In addition to this, I'm also interested in cloud and edge computing. Here we are talking about devices that are attached to the internet. They produce data. The data is being submitted to the cloud. The analysis is being done on the cloud. Naturally, some smaller analysis can naturally be done also on top of the device in case the device is powerful enough. Examples for what I've listed here in pictures is for example, a Raspberry Pi cluster, and that serves either as an edge device or as actually a computational device, because we use it to simulate essentially a cloud. Another aspect is for example, our environmental robot boat that we are working on. And that is a boat that we are launching on a lake to take environmental measurements, to produce data that then is being submitted to the cloud, which we then analyze. So what we also need to be considering is when we are talking about big data, sometimes we need to have big data resources. So we have a cluster on which we are calculating it. But the Raspberry Pi clusters allow us to mimic such a large scale infrastructure and do provisioning on them and create, for example, as one example, in federated edge computing cluster, or just a federated cluster, where we combine multiple clusters with different authentication and authorization and combine them into one single unit. This also sometimes was being called good computer, but we are not doing here plain good computing. We are doing here cloud computing, where on these clusters we are running cloud services, and these cloud services are federated. So we're talking about federation of cloud services. Another interesting topic is here an example of an application actually. And this is an application to measure scientific impact and to conduct an analysis. As part of this, we have created a pretty extensive architecture that is a mashup that provides us with 60 million data entries on which we are trying to identify if a particular compute resource has actually been resulted in publication and they can be attributed to them. As part of this, we are working together with the e516 project sponsored by NSF, which is the largest supercomputing set of machines within the United States. And we are analyzing all of the publications of this particular project. And we are identifying if the users of such infrastructure have more citations than the users of their peers that don't use such infrastructure. The software architecture is an integration of database mashups. As I said, it's already 60 million. It has a REST service layer, so which we can interface to multiple different other toolkits that reuse our services, and also a graphical user interface. Third-party databases can be integrated as indicated in this architectural view. Naturally, when we are looking at the scientific impact analysis, we have to apply some statistics, and we have here given some examples of statistics. I will not go in this lecture much into detail, but just to let you know, this is we have to display some graphs. We have to maybe outline where, for example, the impact is the biggest within the country. So we have maps that actually do this. And we have a summary chart. Naturally, we have many more charts, but it actually showcases you that it's not just important to create a number in a statistical sense, but also convey the material in a convenient fashion to it. But without the analysis and without this data, you certainly cannot conduct such a display. So display by itself is not meaningful. We have to actually go ahead and do the hard number crunching. Naturally, this leads to publications. Certainly, we as researchers need to be learning how to publicize our results. And here are some examples as part of the scientific impact analysis. And these results have actually been received some notable feedback from the e516 user community as well as the leadership. The last portion I'm interested in is teaching, and I will be going into the 3 different portions that I actually teach. The first one for this semester is e516. I also taught e523 and 524 in previous years, but this year we are focusing on engineering cloud computing, and in this particular class we will be giving you an introduction to the definition of cloud computing. We will be giving you an introduction of what actually the big data reference architecture is that is being promoted by NIST. And we will be actively contributing to the NIST and data reference architecture. And this allows you to become potentially a co-author of a document, and that is being issued by NIST. I think it cannot get much better than that. So this is a really cool class that not only gives you an introduction to what you can do, but it gives you also an introduction that you can do something, and that the stuff that you're delivering has actually meaning and can be read by others. We will be looking into an infrastructure as a service model, for cloud computing. We look at OpenStack, Azure, and Amazon Web Services, possibly also Watson. We look at virtualization such as QEMU, KVM, and virtual machines. We look at containers, such as also used in Docker and Kubernetes. We will give you an introduction to programming the cloud. We give you an introduction on how do you formulate REST services that you're running in the cloud, how to use MapReduce and Hadoop in theory, as well as Spark. We will introduce you to concepts such as messaging and GraphQL. A new component that we have added this year is this Go for Cloud, where you will be able to investigate how to use Go, the programming language Go used by Google for cloud computing. The last component will be talking about edge computing and the cloud, such as the robot boat that we have. And here we will be doing some image analysis on the cloud itself, and that can be part of your projects, for example. One thing to note in this class is we will not have typically exams. I try to avoid that. I only will use exams if I find it absolutely necessary. Instead, we will be using a project to demonstrate to us. You will be using a project to demonstrate to us that you have achieved comprehension of the material and can create a full project, including its documentation and presentation. Independent studies can actually be done with me. These are typically similar to classes. However, they don't actually have a lecture, so they are more independent in its form. Essentially, it's a more intense project that you have been exposed to in the class, and they typically require lots amount of research, lots amount of programming, and hopefully a publication at the end. And certainly I have lots of experience in publications. I have over 100, and I stopped counting at that point. So help me either through independent study or your project that you do as part of your classwork to create a high quality publication that we can push out. In addition to this, I also do everything as an open source software project. So that means you can find all the work that we are doing in GitHub, either in Cloud Mesh, which creates a multi and hybrid cloud and container computing toolkit, the NIST Big Data Reference Architecture, virtual clusters, where we, for example, create a client tool for one of the largest educational supercomputers in the nation, and cloud-enabled intelligent environmental robot boats that I'm developing. And you can choose them, or you can produce even your own ideas and discuss them with me. I'm very open to any idea in cloud computing that you may be wanting to research further, either in open source projects or in independent study or in the cloud. With this, I would like to close this short introduction of mine and emphasize that whenever you do a project with me, cloud is somewhat involved, and that can have many forms, and also cloud that reaches out to certain other things such as applications, as exemplified by scientific impact analysis, or edge computing, such as amplified by the robot boat that I introduced you. Thank you very much, and please don't hesitate to contact me either through my email or if you're taking a class through Piazza. Thank you.